Hello. Today we'll look at some examples of rate of change and slope. I apologize that my rate is whited out, but this should say rate of change and slope. All right, so just a few definitions because this is not a lesson. It's just showing you how to work the problems. It says the constant rate of change of a line is called the slope of a line. Slope is the measure of the steepness of a line. The steeper the line, the greater the slope. Notation M stands for slope, so we usually use M for slope. For any 2 points, the slope of a line connecting them can be determined by dividing how much the line rises vertically by how much it runs horizontally. Constant rate of change. A function has a constant rate of change M, which is also known as our slope, if for any change in the independent variable, the dependent variable always changes by exactly M times as much. All right, and here are the formulas that we use or we refer to for slope. So slope is my rise over run. So just like the other slide said, it just talks about the vertical and the horizontal distance. Another way of thinking about it is the change in y divided by the change in x. So when we're talking about change, that is subtraction, and this is what this formula represents here. So m is always going to be equal to y2 minus y1 divided by x2 minus x1. So let's do a couple of examples. So first I have some examples of us finding slope with an actual graph. So here I have a graph and I can take any points that I want from this graph to find the slope. I can use this point. There's 2 points that are highlighted. So let's use those 2 points. So this point is going to be at -1, 1. I'm sorry, I should have said -1, -1. I misspoke. And this point is at 2, -2. And if you recall, the formula is y2 minus y1 divided by x2 minus x1. And now you're probably saying, well, which one is the first point and which one is the second point? It doesn't matter which one you choose to be the first point and which one you choose to be the second point, as long as you make sure those values stay together. So let's say that this is our first point and this is our second point. So that means this is our x2, y2, this is our x1, y2, x1, y2, y1, excuse me. All right, so then I'm going to take my y's first. So that's going to give me -2 minus a -1. So remember the y goes first. Some students missed that part. Divided by my x2, which is 2, minus my -1. And so now I just evaluate that. So that's -2 minus a -1, which gives me -2 plus 1. -2 plus 1 is -1. And 2 minus a -2 is 2 plus 1. So 2 plus 1 is 3. And this absolutely makes sense for our graph because remember, slope, we can determine if it's positive or negative by looking at the direction that it goes in, just like we're reading a book. So we read a book from left to right, and it's going down the hill. So that means the slope should be negative. All right, the next one. Again, we can choose any 2 points. I can choose this point here, this point, this point. They have 2 points highlighted, so I'm going to go ahead and use them. So this is at -1, -1, -4, and this one is at 0, -1. So again, it doesn't matter which one I choose to be my first or my second point. I'm going to say that this is my first point, and then this one is my second point. So this is my x2, y2, x1, y1. So we're going to plug this into the formula that we have here. This is going to give me -1 minus a -4. I'm going to put an M here. over 0 minus a negative 1. And that gives me negative 1 plus 4 over 0 plus 1. And that gives me 3 over 1. And this again makes sense because just like I'm reading a book from left to right, I see that my line is going up the hill, so my slope is positive. All right, let's do some more. Again, we're going to use that exact same formula. We write it here. So that's m equals y2 minus y1 over x2 minus x1. And for each one of these, I'm going to say that the first point is my first value is my first point, and my second value is my second point. So I'm not going to try to confuse myself or anything like that. And I'm just going to go ahead and plug it into the equation. So that is y2, which is 14 minus 10 over negative 7 minus 8, which gives me 4 over negative 15, which is just negative 4/15. The next one, again, this is the first, the second, so that's going to give me 2 minus 1 all over negative 17 minus negative 3, which is 1 over negative 17 minus negative 3 is negative 17 plus 3, so that's negative 14. So I can just rewrite this as negative 1 over 14. Because remember that if my negative on a fraction is at the bottom or the top, the whole fraction is negative. Okay? And if both of them are negative, then the whole fraction is positive. And both of them are positive, then the whole fraction is positive. All right, let's do the next one. I have negative 10 minus a negative 4. These are my y values first. Divided by negative 12 minus a negative 20. And these are my x values next. And that's going to give me negative 10 minus negative 4, which is negative 10 plus 4, which is negative 6. And this is negative 12 minus a negative 20. So that's negative 12 plus 20, which is 8. I have to always reduce. So that's going to reduce to negative 3 over 4. All right, last one. We have negative 8. Put it on here. Negative 8 minus a negative 5 all over 0 minus a negative 12, which gives me negative 8, negative, negative, plus, so that's negative 8 plus 5, which is negative 3. And then 0 minus minus, so that's 0 plus 12, so that's positive 12. Again, I have to always reduce, so my slope for this one is equal to negative 1/4. Let's go on. All right, so now let's put this rate of change into action now. Let's see how it actually applies, because we're actually talking about how something changes over time. So it says the graph, or doesn't necessarily have to be time. All right, the graph shows the height above the ground of a rock climber over time. So it says calculate the slope. So that's the first thing we'll do. I'll say this is my point 1 and this is my point 2. So my slope is going to be 0 minus 26 divided by 8 minus 0, which is negative 26 over 8. And remember, we have to always reduce. And that's going to reduce to negative 13 over 4. Okay, so that's negative 13 over 4. I could put this in decimal form. I prefer for fractions to stay in fraction form just because of the way that we graph lines. I can use it as my rise over my run. It's totally up to you though. I'm going to leave this in fraction form. And it says interpret the slope as a rate of change. So what does this mean to me? What does this mean to me? It means that the mountain climber is decreasing in height of 13 meters every 4 seconds. That means he's flying down that rock. So every 4 seconds, he is going down 13 meters. All right, let's go to the next one. All right, it says the graph shows the relationship between temperature and altitude. So first we'll calculate the slope. So this will be my first point, and this is my second one. And so that's going to give me 13 minus 25 divided by 2200 minus 200, which gives me negative 12 over 2000. I have to reduce that, of course. So that gives me negative 3 over 500. Again, you're welcome to put this in decimal form. I choose to keep it in my fraction form because I like to interpret my slope as the temperature decreases by 3 degrees Celsius every 500 minutes. Sorry, not minutes, meters. So this is meters in altitude. Remember I said time the last time. That's why I had to take it back because we're not always dealing with time. So the temperature decreases by 3 degrees Celsius every 500 meters. All right, let's do one more. It says the price of a loaf of bread increased from 1.45 in 2003 to 1.78. And I'm saying that totally and completely correct. We're dealing with money. So I should say $1.45 and $1.78. What is the average price increase per year? So I have 2 points that I can use. And so I'm going to do my exact same formula. So this is point 1 basically, and this is point 2. And it says the average price increase per year. So my years is actually going to be my x value. And so it's in reverse order. So we'll put that. So we'll say y2 minus y1 over x2 minus x1. And so that gives me 178 minus 145, or $1.45. I don't know why I keep saying that. I apologize. 2006 minus 2003. And that gives me 33 cents divided by 3, because 2006 minus 2003 is 3. And this time I did put it in decimal form because I'm dealing with money. So that means it's 11 cents. So that lets me know that the average price increase per year is 11 cents. Okay. Let me do one more. I want to talk about those special cases. So we have V for vertical line. So whenever I see a vertical line, my slope is undefined. It's also going to look like an equation like x equals some value. So like example, x equals 3. H stands for horizontal. And by the way, this is an acronym Bucks-Hoy. Bucks-Hoy. Horizontal line. So this is my vertical line. And this is actually at negative 3. This is at x equals negative 3. All right, my slope is undefined. Next, I have horizontal line. And I'm going to run out of time. I'm sorry. The slope is 0. And y equals is my equation. So here I have y equals 2. It's my vertical line, and my slope is equal to 2.